Now to create the virtual switches, in my Hyper-V Manager, I'm going to go to the Virtual Switch Manager. Now I have the one virtual switch we created earlier, which I named vSwitch. But when I create a new virtual switch, and you can create as many as you like, it'll ask you what type you want. External. With external, it says create a virtual switch that binds to the physical network adapter so your machines can access the physical network. Internal, the wording of this is important, creates a virtual switch that can be used only by virtual machines that run on the physical computer and between the virtual machines and the physical computer. The and between. So what this means, the name of this host I'm on right now is testdev. If I create an internal switch, then this virtual machine I'm on could connect to a shared folder I have on the host. So you can access resources directly on the host. And you can talk to virtual machines on the host that are connected to the same switch. But you can never connect to the network. You can never connect to the internet. So just think of this as connecting to other VMs and the host. If you choose private, creates a virtual switch that can only be used by virtual machines that run on the same physical computer. So you can only talk to other virtual machines that use the same switch. Now, what I'm going to do is click Create a Virtual Switch. Now, you can make those changes here. If I want this virtual machine to connect to the internet, then I simply choose External and I select my network adapter. Now, when you do that, you will always allow the management operating system to share this network adapter because this network adapter is shared because I only have one network adapter. So the host uses this network adapter and the virtual machine uses the same network adapter. So it's shared. If you added a second network adapter, like physically, to the server, then you would have both network adapters would show up here. What you could do is have the host use one network adapter, and you could tell the virtual machine that it has exclusive access to this network adapter. It gets full throughput. Only this virtual switch and virtual machines that connect to this switch would actually use that network adapter. Along with that, you can enable single root IO virtualization. That is the weirdest name ever. But what single root IO virtualization means, you can actually bypass the operating system and connect directly to hardware. So with this, you have your virtual switch, a virtual machine connects to it, and the virtual switch is connected to the network adapter. When you enable this SRIOV, single root IO virtualization, the virtual machine can actually directly connect to the switch, and that directly connects to the network adapter. It does not have to pass traffic to the host operating system and have the host pass it to the network adapter. Without single root IO virtualization, your host would actually pass that traffic to the network adapter. Older operating systems didn't support this single root IO virtualization. Well, Server 2016 supported it, but very older operating systems did not support that for various types of hardware. So ideally, we would choose that, and you would have enhanced throughput. If we wanted internal or if we wanted private, we could simply select that here. I'm going to create a private switch, and I'm actually going to name it private. And I'm just going to choose OK. Now, if I go back to RTS Serve 2 and go to Settings, for the network adapter, where it says Not Connected, now if I go to Virtual Switch, I will get a list of every virtual switch I created. If I choose the private, and I'm going to choose Apply, this virtual machine is now on that switch I named private, which means it can never connect to the internet. It cannot connect to the host. The only virtual machines it can connect to would be virtual machines that are on this same switch named private. My RTS Serve 1 and RTS-DC1, they are actually on the switch named vSwitch, which means now RTS Serve 2 could never communicate with those because they are on two completely different switches that are not connected to each other. Think of that as if you were in a room and you plugged an Ethernet switch up and you connected two computers to that switch. But that's all you have. One switch and two computers connected to it. Those computers could only communicate with each other. They can't connect to network resources or anything other than each other because they're the only devices connected to that switch. This is the same concept. This would truly be like having two separate switches and you have computers just connected to one switch or the other, but there's no connection between these switches. So now you basically have two isolated networks in your environment. Very useful for test environments. Now, if we were to create a VLAN, now you would normally do this with an external network. A VLAN actually breaks up your network. So let's say I'm in an environment where I have telephones that use voice over IP. You'll see many phones like Avaya, Cisco, and others where they have network ports on the phone and they have a network cable, like an Ethernet cable, plugged into the phone. Well, that traffic from your phone flows through the same network as your data. It's going through the same routers, switches, same cables. So what is almost always done is you will create these virtual LANs, or VLANs we call them. I could have one virtual LAN that is only for telephony traffic, like all my voice traffic from my phones, and I could have another VLAN that's for data from my computers. So what that means, there's no chance from a computer you could ever connect to a phone. You couldn't ping the IP address of a phone or anything like that. So what it does is break up your network into two or more networks. If I put this on VLAN 2 right now, I'm telling this virtual machine, RTS Serve 2, that it can only connect to other virtual machines if they are on VLAN 2. If I were to go to another virtual machine and say, you're on VLAN 3, those two virtual machines do not connect to each other. Now, this is not something that you normally use with virtual machines. What this does is integrate with your physical network. A real life example that I've configured multiple times. Let's say in our environment, we have all of our phones on VLAN 2. So let's say we have Cisco telephony equipment. My phones are on VLAN 2, my voicemail servers, all those things are on VLAN 2. VLAN 3 has all your data, so your servers, all those things are on VLAN 3. But I build a virtual machine, and this virtual machine is actually my voicemail server. So this virtual machine needs to communicate with all my phones. Then for this virtual machine, I would make sure it's on the same VLAN, VLAN 2 in my case, with all my phones. Then when I go to another virtual machine that's a file server that's just passing data, I would make sure that virtual machine is on VLAN 3. So this would simply match your physical network, however that's defined. Now, if you are just a Hyper-V administrator, we'll say, you really don't have any idea what this stuff is supposed to be until a network administrator actually tells you. Because network administrators would be the people that create VLANs, manage VLANs. You would just make sure that your virtual machines match whatever they need to integrate with your physical environment. Now, in addition to the VLAN, you could also enable bandwidth management. The only number you really ever change here is maximum bandwidth. So let's say this server I'm creating has videos on it, and you can stream videos off of this server. I want to make sure that it does not consume too much bandwidth. You could simply specify that I want this to stream at no more than 2 megabits per second, or whatever number you believe is appropriate. So this will never saturate your connection and create a bottleneck anywhere on the network by just sending too much traffic. So pretty powerful overall. But these virtual switches, I'm just going to cancel that screen there. But if we go back to the virtual switch manager, at any time, you could modify any of these virtual switches. So if I want to connect to the internet, I could simply change this to be external, choose your network adapter and click OK, and it would reconfigure itself as an external, and now you would be able to connect to the network from any virtual machine that was on that switch. I'll do this often in my test environment when I need to download something from the internet, or I want internet connectivity for a short amount of time. Like when we activated the server, you just have this connected to the external network. Once you have downloaded whatever you wanted, once you've activated the operating system, you're just done with network connectivity, and now you want some type of isolation, you can simply go change it back to private, and now it's completely cut off from network level resources. So very useful. But that's what we wanted to look at in our virtual switch configuration.